First, I don't have my tablet working yet, like a yin yang. Okay. So worksheet 24, there's some warm-up problems at the top. We're going to start with those. This one says find R to T. What would I need if I want to find this side over here? I'm not going to call it side S because my S's look like 5s, or my 5s, so I must call it X for a minute here. Anybody know what law I need to set up to find that piece? Oh my goodness, I can't talk. This is my theory, guys. I should always use law of sines unless I can't. Fair enough. Because law of sines is much easier, right? Can I figure out how to set this up across from each other and have a proportion? Yes. So is that a 29 over 41? And then a 33. Am I going to have to worry about two solutions here? No, that's only when you're doing second sine or inverse sine. You don't know whether it's acute or obtuse. Okay, so 41, what mode should I be in? Degree. Sine of 33 divided by the sine of 29, and I had to close some parentheses in there. Anybody get 46.059 or 46.1? All right, angle B. Can I do law of sines on this one? Nope. Okay, to find angle B, is that not working for you?
I see what I did. I didn't put the 1 after the 4 because I realized I forgot my
Oh,
calculator.
okay. You good?
Yeah.
All right, so this, if I'm trying to find angle B, would be this. I'm just writing this out because we need a little more practice. Ooh, there's a 2 in there, isn't there? So what numbers am I putting in? To find angle B, across from the B is 10 squared equals 5 squared and 7 squared minus 2 times 5 times 7 times the cosine of B. Okay, I'm going to show my work so that this makes sense, but what are we moving over there? We can't move this stuff, right? Because this is all multiplied. So I have the 10 squared, I can subtract the 5 squared and subtract the 7 squared over there. And then I have a negative 2 times 5 times 7 times the cosine of B. So then I need to, after I figure out what that is, divide, right? By negative 2 times 5 times 7. And then I'll have to do the inverse cosine. Showing all my work so that we're doing this right, because I tell you, so many people set these up wrong. I have positive 26 over negative 70. Anybody get those numbers? So then if I do inverse cosine of that in degrees, 111.8. Why did I get an obtuse angle?
Because the bottom number is greater than one of those.
Actually, it has to do with the fact that it was negative. Inverse cosine. Do you remember the inverse cosine when we colored the unit circle was in quadrants 1 and 2? It's negative in quadrant 2, so it has to be an obtuse angle. Okay. And then does it make sense for this picture? And it doesn't always make sense for the picture, but yes, that one does. So, all right. I'm on to number 3. We want side EF or D. How are we going to find that? Law of sines? Well, how can we set that up? I don't think law of sines is going to work, right? Because we don't know anything across from anything. Yes. This is a side angle side situation. So how can we find D? D squared equals, it would be E squared plus F squared minus 2EF cosine of D. So I'm going to have D squared equals 40 and 49. Is that what those numbers say, guys? Okay, those are added. Minus 2 times 40 times 49 cosine of 53 degrees. Remember, you have to have law of cosine memorized as well as law of sines. All right, this one, I would type it all in at once, very carefully. 40 squared plus 49 squared minus 2 times 40 times 49 times the cosine of, what was the angle, guys? Thank you. Okay, big number. Why is it such a big number? Because that's D squared, right? So then I have to square root that answer. I got 40.5. Anybody else? Any questions? Okay, please be careful that you show work on these so that if you type something, I don't have to call it a concept error necessarily. Does that make sense? All right, I have an extra, and I have an extra on purpose. I found an extra where you might have two solutions. Triangle ABC, they want us to find angle A. If angle B is 56 degrees, side A is 35 centimeters, side B is 34 centimeters. How would we set this up? So the sine of is across from, in the same way, sine of A is across from, and all I know is that A should be more, because it's across, it should be more than 56, right? Okay, so I do 35 times the sine of 56 divided by 34, and I get a funky little decimal. .8534. And then I do second sine of that. And any time I do second sine, I should be thinking there could be two answers. So I get 58.6. And if I do 180 minus that number, I get 121.4. Now, a lot of times you can eliminate that. Like, can I have a 56 and a 121.4? That'd be 177, but it leaves room for a tiny little third angle, so it is possible. Okay? So you have to give me both of these. If we were solving, now you would also have two different solutions for over here. One based on, and for this angle actually, one based on the 58.6 and one based on the 121.4. But I'm not going to ask you on a quiz to solve the whole thing. I'm just going to ask you for the missing angle. Everybody good? All right, you have an application on your sheet. It says, if this is a complicated word problem that I would never ask you to draw by yourself because I don't know that I could figure out what they meant by this. But given the picture, I think we can follow. A lamppost tilts toward the sun at a 2-degree angle from vertical. So it used to be like straight up, but it's managed to lean over 2 degrees. So that actually makes this entire angle 92. It casts a shadow. Okay, guys. If I send you out to measure a shadow, I hope you're gonna put the tape measure on the ground, right? To measure the shadow, I got people putting shadows in weird places. Shadows on the ground, 25 foot. The angle from the tip of the shadow to the top of the lamppost is 45. Find the length of the lamppost. Okay, I think we need to find the third angle, don't we? This little angle up here. So we have 180 minus 92 and 45. Yeah, because this is the angle that's across from this 25. What do we get? 43. So then that 43-degree angle, if I get rid of everything else, we now have a 43, a 92, a 45, a 25 out here, and an X. Does that help you see how we'd have to set it up? So the sine of 45 is across from X in the same way the sine of 43 was across from 25. All right, typing 25 times the sine of 45, close parenthesis, divided by the sine of 35. Do I have to do second sine or anything crazy? No, it's just a missing length. So the length of the lamppost is 30.8 feet. Did someone else get that? No? Yes? Okay. Oops, sorry. All right, now there will be somewhere you don't have a picture, but that description was kind of wonky, so I would have given you a picture. The next thing we're going to do is learn the two area formulas. And I have some extra slides on this, but this is Heron's formula. And it is on your reference sheets that you will have. It's at the back at the top. Make sure you know where that is. On the blue reference sheet, there's a box that says area, right? I think I even put a slide in. It looks like this. So there are two area formulas. One is all nasty, it's here, and the other one is much more straightforward, but they're both on there, okay? Anybody have a question about what's on there? Now, this nasty Heron's formula says the measures of the sides of a triangle are A, B, and C. Then you can calculate the area by, look, guys, first calculating what's called the semi-perimeter, halfway around. So you add up all the sides and divide by 2. Or multiply by 1/2. Once you have the semi-perimeter, you take that S times the difference between S and A, S and B, S and C, you multiply all those together and then you square root. The man who developed that is crazy, I think, because it's messy. It'd be fun to look at the proof someday of that. But for today, we're just going to practice this. Now, I would like to teach you the shortcut on your calculator. You want to try that? Because there's a way to make this a little less cumbersome. So first you would calculate the semi-perimeter. So quickly type in on your calculator 38, 51, 45. 38 plus 51 plus 45. Then I'm just going to hit enter and divide by 2, but you could have done parentheses and all kinds of fun. So the semi-perimeter S is 67. Everybody got that? Okay, now we can store that in the calculator. We're going to use this store button over on the left here, STO. And I'm going to store it into X because that's an easy one to find. I know where the X button is. So I'm going to say store into X, enter. Now, anytime I hit X, it's going to put a 67 on the screen. So I'm just going to go second square root, X parenthesis, X minus, what are the three sides? 38, close parenthesis, parenthesis, X minus 51, close parenthesis, parenthesis, X minus 45. Because now I didn't have to type 67 all those times, right? 67 is not that big of a deal, but if it's 31.25 for your semi-perimeter, it's a miserable. All right, so then you hit enter, and it already square rooted in everything. So the area is 827. Does that happen to be what this says? Oh, whew, look right there, 827. Okay? Now, so two things. You store into any variable you want, and then you just use that variable. The second thing is students freak out. Well, now there's a 67 stored in there. It doesn't matter. There's always something stored in your X. It's based on what you last graphed. Just don't worry about it, okay? It'll right over the top of it. Don't ever worry about that you stored something. So let's try this example you have on your worksheet, number 5. If you add these all up, 36, 20, and 22, 30, 78 maybe, anybody? Divided by 2 is 39, is that the S? Did anybody get that far? Okay. So then you can store that into X if you want. And then we're square rooting 39, or X, times 39 minus 36, times 39 minus 20, times 39 minus 22, or 39 times 3 times 19 times, oh, I don't know what that would be, 17? That's why just doing it all in the calculator is easier. Oh, I got a lovely, anybody do it the long way and get that number, 37791? Or did I mess something up? Okay, whoa, what's that? Interesting. What was it, 39, store into X. No one's yelling at me, so I think I did something wrong. Square root of X times X minus what?
22.
And then X minus, and X minus,
Does it matter?
nope, nope, because you're multiplying. You can multiply in any order you want. So I got 194.4. I don't know if that's equivalent to what I had. I had square root of 37791 when I was trying to do some of it in my head. It is equivalent. Woo! So I didn't, my notes here aren't wrong. It does turn out 194 point what? 194.4. And that is square inches because it's an area. Do we need to do more of those? I think there's 2 more on your worksheet, isn't there? Want to do 1? Just so you got that store thing cemented in your head? Which one you want to do? 7? Okay. 8 plus 12 plus 13. I think we're going to get a decimal. Because that's 33 divided by 2, right? 8 plus 12 plus 13, enter, divided by 2 is 16.5. So this would be a good one to store. So I'm going to put 16.5 into X, and then I'm actually going to type X times X minus 8 times X minus 12 times X minus 13. Now, if I was you on the quiz, I would do this kind of problem twice probably. Make sure you get the same answer, because if you type something wrong, you can't get a 5, right? So I got 46.999 or 47 centimeters squared. Brandon S., are you coming to make up your quiz sometime? Not till Friday? You're gonna have another quiz by Friday, okay. Are we good? I don't need to do 6, right? All right, the other area formula is when you know 2 sides and an angle in between. I didn't bother to put all three versions of this on your quiz, okay? It's just whatever two sides you know and the angle in between. So it looks like this on your reference sheet. But does everybody understand it could be 1/2 like BC, sine A, etc. Okay? It's two sides and the angle in between. So it says we should do 9 for sure, but let's practice 8 real quick because I think this is a nice short thing to do. RST, where R is 50 degrees, that's supposed to be an R. Whew, that's a bad R. S is 12 yards, side T is 14 yards. Oh, that's set up real nice, right? For this area equals, how does the formula go? 1/2 or 0.5 times the two sides, 14 and 12 in any order, times the sine of the angle, as long as you're in degrees. So 0.5 times 14 times 12 times the sine of 50. I got 64.3. Anybody else? Label? Square yards? Almost all the questions on the quiz I made sure had units so that you could give me labels. I think this one is tricky because I don't think it gives us everything we need. M, N, P, oh, okay. I mean, mine doesn't look obtuse to begin with, but I think I'll put P up here so that it looks a little more like it could be 110. Side, or angle N is 25 degrees, and side N is 14 feet. Okay. I can't do either of the two things we just learned for area. We could certainly find another side and then use this law or this sine formula. I don't think we want to find all three sides and do that Huron's formula. But if we have a 110 and a 25, 135, is that 45? 60, 70, yeah, okay. So now we can find this missing side here by law of sines. Is across from x in the same way the sine of 25 is across from 14. So 14 times the sine of 45 divided by the sine of 25. 23.424. We could certainly just use 0.4. It doesn't matter. We'll be close enough. Any questions? Everybody getting that? So then how am I going to find the area? The formula is 0.5. What two sides do we know? 23.4. And times the sine of, what's the angle in between those? The 110. I don't know if I can move this. Oh, good. So 0.5 times 14 times, what was that other side? 23.424 if I use all the decimals that I wrote down. Times the sine of 110. 154. Did anybody use less decimals and get a different answer? Yeah, it might be a fairly significant difference depending on how you rounded. 154, 1.1, and 153.9. I would take either one. So just show your work. So it's right around 154. Is that what we said? Square feet. All right, we're just have a quick application here. This is yellow over here, And what's the same as the yellow? Can you tell? Because it says it's symmetrical. Yeah, I'm thinking that the blue over here is the same size as the yellow, right? Because of the symmetry. So we know what about this yellow triangle? It has a 45 here, I think, and 100 here, which would make 35 here. Does that work? I think so. All right, and it has a side of 6.5 that would be next to the 100 here, so here. And we're supposed to find the area. So can we maybe find this side? So the sine of 35 is across from x, as the sine of 45 is across from 6.5. 6.5, I can't type, times the sine of 35 divided by the sine of 45. Anybody get 5.27? Okay, so now to find the area, we'd have 1/2 or 0.5 times 6.5 and 5.27. And the angle in between those two would be 100. I left the whole decimal in and got 16.9. Did anybody round the decimal?
I got 16.86,
Yeah, I got 16.96 if I rounded this to 0.53. So somewhere around 16.9 or 17. I'm going to put 16.9, and that was square feet. Now, it says it takes 3 coats to make this on the side of a barn. That barn wood sucks up that paint something fierce. So we're going to triple that, because that's the area we have to do, because they just want how much yellow paint. So times 3, we now need to cover basically 50.9 square feet. And 3.5 ounces will cover a single square foot. So what do we need to do? 1 square foot will get covered by 3.5 ounces, right? So we need how many ounces down here? So yeah, we just need to multiply. So times 3.5, I don't know, 178, 179, somewhere in there. Anybody getting that? What's wrong? What?
You cubed the feet.
Oh, should be squared. Thank you. That was an easy fix. I thought I did something wrong with the math. Just the labels. All right, so I got about 178. How much paint will be needed? Approximately 178 ounces. Now, I don't know that you can buy that much paint by the ounce. Is there 64 ounces in a gallon? I don't know. I don't care. I'm done. Are we good? I think you need about 3 gallons. But I could be totally off on the 64 too. That might be quarts. Okay. A blimp hovers over a soccer stadium. Players 500 feet apart at opposite ends of the stadium with the blimp between them measures the respective angles of elevation to be 63 and 72. How high is the blimp? Okay, what are people going to do that's not correct?
Use the actual measurement of shock socket.
You what?
In the socket.
Oh, yes, but the other thing I'm thinking is that they're going to cut this in half and say this is 250. Is that 250? And they make it look like it's right over the top, but it's clearly not, right? Because one guy has to look up more than the other. So we have to treat this as a giant triangle first. So what is this angle if we have a 63 and a 72. I got 45 again. I feel like everything's 45 today. So this is a 45-degree angle. Now what? I want this height eventually, but I can't find that until I find one of these, okay? Because I want to be able to use that right triangle, and right now, all I know about that right triangle is like there's a 63 there. I don't know anything else. Until I know a length in this triangle, I can't use it. So if I say the sine of 45 is across from 500 in the giant triangle, the sine of 72 is across from this guy. That will give me a number for that side right over there. 500 sine of 72 divided by the sine of 45. Anybody get 672.5? No, maybe? Did not? 500 sine of 72, close parenthesis, divided by the sine of 45. Did I not do something right? What'd you get, Brandon? Isabella, did you type this one? What did you get? S672? Did you close a parenthesis? 500 times the sine of 72, close parenthesis, divided by the sine of 45? You put a number in wrong? Okay.
27.
Now, we want the height. So now if we take this little right triangle out, you can use law of sines again if you want with a 90 degree, but you could also do what? Opposite over hypotenuse is the sine of 63 degrees equals h over 672.5. Just right triangle trig, SOHCAHTOA stuff. I have 599.2. I left the whole decimal in though. It's about 600 feet. Whew. If I had rounded 672.5 times the sine of 63, still got, okay. How high is the blimp? 599.2, or about 600 feet up. We good? Oh no, the McBiggs. Plan to fence a triangular parcel of land. One side of the property is 75 feet long and forms a 38-degree angle with another side of the property which has not yet been measured. So this is unknown. The remaining side of the property is 95. Approximate to the nearest tenth the length of the fence needed to enclose the area. So what do we need to do? We need eventually to find the whole what? Perimeter. We need to find this side. How are we going to do that though? Oh, this is kind of complicated. The only thing we can find right now is this angle down here, right? Then we'll find that angle, and then we can do law of sines again to find that side, and then add up all three sides. Okay. Sine of 38 is across from 95. In the same way the sine of, oh, we'll call this M for McBiggs, is across from 75, okay? Now we're doing second sine. 75 sine of 38 divided by 95. I got like 0.486. We do second sine of that. (29.1 degrees maybe? If we go with 29.1, then we have 180 minus 29.1 and minus 38. I got that this makes 112.9. Anybody? So then what? Are you getting those numbers or am I crazy? Okay. Sine of 112.9 is across from x in the same way. I'm going to go with the 38 and 95, okay? Could this when I did second sine, I should have said or, and I would have had like 150-ish. Can this angle at M be more than 38 degrees? Wasn't the 95 already across from the bigger? So it can't, it has to be less. So that's why we didn't have to worry about that. All right, what did you get for X? I didn't type yet. 95 sine of 112.9, close parenthesis, divided by the sine of 38. 142.1, anybody? Now what? Add them all together. So 75 plus 95 plus 142.1. They need a total of 312.1 feet of fence. If it said they should add 5% error for waste or something, how would you do that easily? Okay, and you're gonna get like 15 feet. Is that the answer? Oh. Is there a faster way? Yes, you could have multiplied this times 1.05 and you got 327 or 328 feet if they had a 5% error. I think there's one on the worksheet that says that, but I don't remember if it's assigned or not. So this is what you need to do tonight, or get started on, because tomorrow you will have some time to ask questions if you have any trouble on any of these. These are almost all application questions. The first 4 are on 24.5B, the rest are on 25 and 26. The first 4 I think are all area, and then these are just applications. Anybody do last night's and have a question?